Previously, we've looked at the total cost, total revenue, and total profit functions. But from a business standpoint, it's common for cost, revenue, and profit to differ based on how many items are being produced. So for example, cost, revenue, and profit for producing 10 items may be different from producing, say, 1,000 items. So for this reason, it's common for businesses to want to focus on the average, so the average cost, average revenue, and average profit. So let's look at this example. Cafe Mugs Incorporated find that the cost in dollars of producing X coffee mugs is given by the following function C of X. We want to find the rate at which average cost is changing when 81 coffee mugs have been produced. Well, we've defined the average cost function to be C of X, the cost function, divided by X, and that'll give us the average. So that's going to look like 375 plus 0.75x to the 3/4 power. And that is our cost function, and that's going to be divided by x to give us the average cost function. Now we are asked to find the rate at which average cost is changing. So to find the rate at which it's changing, we need to take the derivative. So now in order to take the derivative of this function, notice how we have a quotient. We have a numerator and we have a denominator. So we're going to have to use the quotient rule to find the derivative. Okay, so now recall what the quotient rule looks like. We take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over denominator squared. So we're going to use that to find the derivative. So we're going to start out with the denominator, which is x, times the derivative of the numerator. So now we're going to take the derivative of the numerator. Derivative of the constant 375 is just 0. Moving on to the next term, we bring the exponent down in front. So we have 0.75 times 3/4 x, and now subtract 1 from the exponent. 3/4 minus 1 is going to leave us with a negative 1/4 in the exponent. So that is the derivative of the numerator. Minus, now we copy down the numerator, 375 plus 0.75 x to the 3/4. Now times the derivative of the denominator. The derivative of x is just 1. And then this is all over the denominator squared, so x squared. Okay, now we want to simplify this. So we have a 0.75 times 3/4, which gives us a 0.5625. And then x times x to the negative 1/4 leaves us with x to the 3/4. Minus, distributing the negative sign through, and then that's all over x squared. Now we can combine like terms. We have 0.5625 x to the 3/4 minus 0.75 x to the 3/4. So we have a negative 0.1875 x to the 3/4 minus 375, all divided by x squared. Now we want to find the rate at which the average cost is changing when 81 coffee mugs have been produced. So now we're going to plug 81 into our derivative. And then simplify. And rounding our answer to the nearest hundredth place, we get a negative 0.06. So now in context of this problem, we were asked to find the rate at which average cost is changing when 81 coffee mugs have been produced. And we found that that rate is a negative 6 cents per day. For part B, the revenue in dollars from the sale of X coffee mugs is given by R of X, which is equal to 7.5x to the 0.7. Find the rate at which average revenue is changing when 81 coffee mugs have been produced and sold. We've defined the average revenue function as r of x, the revenue function, divided by x. So that's going to look like 7.5x to the 0.7 divided by x. Now that we want to find the rate at which average revenue is changing, we need to take the derivative. Once again, using the quotient rule, because we have a numerator and we have a denominator. Now the quotient rule looks like denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over denominator squared. So using the quotient rule to find the derivative, we begin by taking the denominator x times the derivative of the numerator, so bringing the exponent out in front, and then subtracting 1 from the exponent, we get a negative 0.3 as our exponent, minus the numerator, 7.5x to the 0.7, times the derivative of the denominator. The derivative of x is just 1. All divided by denominator squared. So now we need to simplify. So we have a 5.25x to the 0.7 when we distribute the x through, minus 7.5 x to the 0.7, all divided by x squared. Now in the numerator we can combine those like terms. We have a negative 2.25 x to the 0.7, all divided by x squared. Alright, now we want to find the rate at which average revenue is changing when 81 coffee mugs have been produced. So now we're going to plug 81 into our derivative here. So negative 2.25 times 81 to the 0.75, all divided by 81 squared. Now when we simplify this, we get approximately a negative 0.0074. So in context of this problem, the rate at which average revenue is changing when 81 coffee mugs have been produced and sold would be a negative $0.0074 per mug. For part C, find the rate at which Cafe Mug's average profit per coffee mug is changing when 81 coffee mugs have been produced and sold. So recall that to find the profit function, what we do is we take the revenue function and then subtract from that the cost function. So if we go back and look at parts A and B, we have that the revenue function is defined to be 7.5x to the 0.7, and then we're going to subtract from that the cost function from part A. So now that we have the profit function, next what we want to do is find the average profit function, which is found by taking the profit function and dividing it by x. So we write down our profit function and then we divide that by x. Now we want to find the rate at which the average profit function is changing. So next we want to find the derivative of this profit function, average profit function. So in order to find that, we've got a numerator and a denominator. So once again, we're going to have to use the quotient rule. So using the quotient rule, we first take the denominator, which is x, times the derivative of the numerator. So taking the derivative of the numerator on that first term, bring the 0.75 exponent down in front and multiply it by 7.5, which leaves us with a 5.25 x to the subtract 1 from the exponent, we have a negative 0.3. Moving on to the next term, a negative 375. That's a constant, and the derivative of a constant is 0. So moving on to the next term, we have a minus 0.75 times x to the 3/4. We're going to bring that exponent out in front using the power rule. So we have a negative 0.75 times 3/4, which is going to leave us with a minus 0.5625 x to the subtract 1 from the exponent. We have an exponent of negative 1/4. So there's the derivative of the numerator. Now next, using the quotient rule, we now subtract off the numerator times the derivative of the denominator. So we copy down the numerator and then times the derivative of the denominator, but the denominator is x and the derivative of x is just 1. And then that's all divided by the denominator squared. We can simplify this a little bit by getting rid of the parentheses and combining a couple like terms. But next, what we need to do is plug 81 into this derivative because we're asked to find the rate at which average profit per coffee mug is changing when 81 coffee mugs have been produced. So now plugging 81 into the derivative and then simplifying, we get that the rate at which the average profit per coffee mug is changing when 81 coffee mugs have been produced and sold is 5 cents per mug, rounded to 2 decimal places.